Hello everyone, my name is Muhammad Iqmal Hakimi. Today I would like to present about our project, Thermometer Body Temperature. As we know, COVID-19 started to spread worldwide in April 2020, and in Malaysia, COVID-19 started to spread in March 2020. As we know, the early symptoms for COVID-19 patients was fever, high body temperature, and etc. In this project, we made a thermometer body temperature to avoid the spread of COVID-19. Next, in this project, we use a few components, which is MLX 90614 temperature sensor. This is used to detect the body temperature. Piezo buzzer. This buzzer is used to create a sound when the temperature is above 38 degrees Celsius. Next, NXP LPC 1768. This component is used to control the system. Our red and green LED is used to show whether the temperature is in the green zone or red zone. And finally, the LED display. This is used to display the number of the temperature for the body. The software that is used in this project is KL Tools by ARM. Okay, next, my group mate will briefly explain the use of the component and the software.
I'm Irshad Mustaqim. So I will explain our theory for our team project. On this slide, we can see our block diagram. We have input unit, the temperature sensor. The scientific name is MLX 90614. It is a contactless infrared digital temperature sensor that can measure temperature from negative 70 degrees Celsius to 382.2 degrees Celsius. This temperature sensor has operating voltage from 3.6 volt to 5 volt. It also has accuracy around 0.02 degrees Celsius, and it has 80 degree of field of view. The distance between object and the temperature sensor are approximately between 2 cm to 5 cm. So for the processing unit, we have NXP LPC 1768 microprocessor. Is a powerful 32-bit ARM Cortex M3 processor running at 96 MHz with 512 kilobyte flash and 32 kilobyte RAM, which makes it far more capable than popular 8-bit prototyping alternative. At the output processing unit, for our output unit, we have mini piezo buzzer. This mini piezo buzzer will buzz when it detects temperature that are 38 degrees Celsius or greater than that. So for our circuit configuration, next, so this is our circuit configuration. On the input unit, we have the temperature sensor. It will send the input to the processing unit. The our processing unit is NXP LPC1768. The processing unit or the microprocessor will send the output to the LED display, LED and also buzzer. If the temperature sensor sends an object that are less than 38 degrees Celsius, the microprocessor will send the output to the green LED, and the green LED will light up, and the LED display will show the value of the temperature detected. But when the temperature sensor sends a temperature that is more than 38 degrees Celsius, it will the microprocessor will send the output to the red LED, and red LED will light up, and the buzzer will buzz for 5 seconds, and LED display will show the value of the temperature detected. Next, I will pass the presentation to Afiq.
My name is Muhammad Afiq, and I will present and elaborate about the coding. For the coding, we use the KL software to build the coding. So this is our coding. First, we must create a file for the project. Then we must add the new item to the source group, which is the LPC1768. Then we write the coding. After that, we build the target and make sure there is no error. After we make sure that there is no error, then we press debug to get the output. Then we press run to see the coding function. For the coding at line 9 until line 17, we declare the input output register to the address. Then from line 21 until line 35, we load the register 0 with the address from pin cell 3 and load register 1 with address 000000. Then we store the register 0 address into register 1. Then we continue to do the same thing for pin cell 0, FIO 1 DIR, FIO 0 pin. Then for line 38, the register 0 will be loaded from the FIO 0 pin, which is the input from the temperature. Then we load the register 1 to register 0. Then we compare register 1 with the value of 38. Then if the value is more than 38, the code will continue to line 43. From line 43 to line 46, this code will turn on the buzzer, the LCD display, and the LED red. Then from line 48 to line 50, this will reset back all the buzzer, LED, and LCD to off. Then go to line 52, which is B loop. Then it will go to line 73 and N. Then if we compare register 1 with 38, but the value is less than 38, the coding will break to line 54, which is from line 55 to line 58. The LED blue will turn on, and from line 60 to line 63, the LCD display for the temperature will turn on, and for line 65 to line 67, the LED will turn off. Line 69 to line 71, the LCD will turn off. Then it will go to line 76 and the sequence is N. If the register 1, the value is 000000303, then the temperature is more than 38 degree. If the register 1, if 00040000, then the temperature is less than 38 degree. Next, I would like to give the presentation to Hazima.
My name is Hazima. I will explain about discussion and conclusion. The input device is MLX90614 infrared temperature sensor, and the output device are green LED, red LED, buzzer, and LCD display, which is to display the input temperature. In order for the registry and the code written is appropriate for MLX90614, the student refer to UM 10360 user manual datasheet. MLX90614 is loaded by the .bin file. The code will be processed by using the montage language in the KL program. The will also understand sensor into the digital signal with the MLX90614. During the completion of this project, the students have faced some challenges. They sometimes get the bug and warning from the KL program while running the code. However, they have successfully overcome the challenges by doing some modification to the code. The code is written using assembly language, which is simpler than other complicated code such as Java and C program. The code is understandable because it uses human language such as CLR as clear, LDR as load, STR as store, and EQU as equivalent, and many more. The code is clearly verified and the alignment is very important to avoid error during compilation. Next slide, conclusion. From the assignment, the students have successfully developed a smart device which can help the community to decrease the spread of COVID-19. However, other standard operating procedure (SOP) mentioned by the government, such as sanitize hands regularly, avoid crowded place, stay 1 meter from other people, and wearing face mask must be a new norm in the community. In this assignment, the students have applied their knowledge such as writing, debugging, and analyzing the design using assembly language of microprocessor-based system. In order to get accurate and successful result, the students gave full commitment on their parts and discussed with each other to resolve the challenges in this assignment. The outcome of this assignment have finally run successfully. Hopefully, it can help the community to lower the cases of COVID-19 in Malaysia. That's all from us. Thank you.